The cheapest carbon fiber road bike available today costs somewhere around $800. 10 years ago, that same budget bought an aluminum frame with entry-level components and no pretense of being anything more sophisticated than that. Today, it buys a full carbon frame, carbon fork, and a complete drivetrain, and the brand selling it will tell you that the material is the same material used in bikes that cost $8,000, that carbon fiber is carbon fiber, and that the performance gap between their product and a bike costing 10 times more is mostly marketing and brand premium rather than genuine engineering difference. That claim is not entirely wrong. It is also not nearly as right as it sounds when a sales page presents it with enough confidence. The cheap carbon bike market has expanded dramatically over the past decade, driven by Chinese manufacturing capacity that genuinely democratized access to a material that was once reserved for professional racing and serious enthusiast budgets. The frames coming out of certain factories in Guangdong and Jiangsu provinces are legitimately impressive for their price point in ways that would have seemed implausible 15 years ago. But the cycling industry, both the brands selling budget carbon and the YouTube channels reviewing it, has consistently overstated how close cheap carbon gets to expensive carbon, while understating the specific ways in which the gap between them remains real, consequential, and in some cases directly relevant to rider safety. Understanding where the money actually goes in a carbon fiber bicycle frame requires understanding how carbon fiber works as a structural material, why the manufacturing process matters as much as the material itself, and what the quality control differences between price points actually mean for the person riding the finished product down a mountain descent at 50 kilometers per hour. Carbon fiber as a raw material is not a single thing. It is a family of materials with properties that vary enormously depending on how the fiber is manufactured, how it is woven or laid into sheets, what resin system binds those sheets together, and how the curing process locks that resin into its final state. The term carbon fiber covers everything from the relatively low modulus fiber used in budget frames, where modulus refers to the stiffness of the fiber per unit of weight, to the ultra-high modulus fiber used in aerospace applications and the most expensive cycling frames, where the same structural performance is achieved with significantly less material mass. A cheap carbon frame and an expensive carbon frame are both made from carbon fiber in the same way that a budget kitchen knife and a professional chef's knife are both made from steel. The category label is accurate. The performance implication of that label is not. The fiber grade difference between a budget carbon frame and a premium carbon frame translates into a weight difference that is measurable and a stiffness characteristic that is perceptible to any rider with sufficient reference experience. A budget carbon frame will typically weigh between 1,400 and 1,800 grams. A premium frame using higher modulus fiber in an optimized layup will weigh between 700 and 950 grams. That difference of 500 to 800 grams on the frame alone is not a marketing abstraction. It is weight that the rider carries up every climb and accelerates through every sprint. And the rider who has spent 6 months on a budget carbon frame before riding a premium one will feel the difference within the first kilometer of the test ride in a way that no amount of specification sheet reading fully prepares them for. The layup schedule, meaning the arrangement of carbon fiber sheets inside the mold and the direction of the fibers within each sheet, determines where the frame is stiff and where it is compliant. And getting that balance right requires engineering investment that cheap frames simply do not receive. The manufacturing process is where the gap between cheap carbon and expensive carbon becomes most significant and least visible to the buyer standing in front of a completed bicycle. Carbon fiber frames are built by laying sheets of carbon fiber pre-impregnated with resin into molds, then curing those molds under heat and pressure in an autoclave, a pressure vessel that ensures the resin flows evenly through the fiber layers and that no voids or delaminations form in the finished structure. The quality of this process determines the structural integrity of the finished frame in ways that are invisible from the outside, and that only become apparent under stress. Budget carbon frames are often produced using a process called wet layup, rather than pre-preg layup. In wet layup, the resin is applied to dry fiber sheets during the layup process, rather than being pre-impregnated into the fiber before it enters the mold. Wet layup is faster, requires less controlled storage conditions for the raw materials, and produces frames that are structurally adequate under normal riding loads. It also produces frames with higher void content, meaning more microscopic air pockets distributed through the fiber matrix than pre-preg autoclave curing achieves. Those voids are stress concentration points. Under the repeated loading cycles of normal riding, they are largely irrelevant. Under impact loading from a crash or a significant road impact, they can initiate crack propagation in ways that a pre-preg frame resists more effectively. If you have been wondering whether the carbon frame you are considering at that price point was manufactured to the same process standard as the bikes it claims to compete with, subscribing means you will get more of these examinations without having to search for them. The quality control differences between factories at different price points are also real and consequential. Premium frame manufacturers invest in non-destructive testing equipment, including ultrasonic scanning that can identify internal voids and delaminations without cutting the frame open. Budget frame production lines rely on visual inspection and periodic destructive testing of sample frames rather than scanning every unit. That difference means that a small percentage of budget carbon frames leave the factory with internal defects that neither the manufacturer nor the buyer can detect, and that will only become apparent when the frame encounters a loading condition that the defect makes it unable to handle safely. The honest verdict on cheap carbon fiber bikes is more specific than either the enthusiasts or the skeptics typically make it. A budget carbon frame from a reputable direct-to-consumer brand with documented quality control and a reasonable crash replacement policy is a legitimate product that delivers a genuine carbon fiber riding experience at a price point that was genuinely inaccessible a decade ago. For a rider who wants to understand what carbon fiber feels like, who is not racing competitively, who rides primarily on smooth roads at moderate speeds, and who treats the frame as a consumable product with a defined service life rather than a permanent investment, the value proposition is real and the performance is sufficient. The problems begin when budget carbon is presented as equivalent to premium carbon in ways that it is not, when buyers make decisions about frame weight limits and riding intensity based on marketing claims rather than engineering specifications, and when the crash replacement policies that budget brands offer as reassurance turn out to have exclusions and processing times that leave riders without a functioning bike for months. The weight difference is real. The layup quality difference is real. The manufacturing process difference is real. And the safety margin difference, meaning the gap between the load the frame is designed to handle and the load at which it fails, is real in ways that matter most precisely in the situations where a rider most needs the frame to perform reliably. Buy a budget carbon bike with clear eyes about what you are actually purchasing, and it is a reasonable decision. Buy one believing that carbon fiber is carbon fiber and that the price difference is mostly brand premium, and you are making a decision based on a claim the industry has been making for a decade because it sells bikes, not because it accurately describes the engineering reality of what is inside the mold.